Hello and welcome to this video. Today we're going to learn about the correlation of rock layers. Up until now, we've been placing events in their proper sequence from oldest to youngest using a diagram of a rock formation. Now what we're going to do is we're going to examine several rock formations and compare them and correlate or match up the layers that are of the same age. So these are relative ages. We still have not placed numerical ages on these events. That is in our next portion of this unit. But what we're going to be doing is we're going to be matching up rock layers in different rock columns based on the rock types and also the fossils. So I'm going to go ahead and present, and we'll go through this material. There's also another activity that you'll be doing. You will either have a manipulative as a Google slide presentation, or you will have paper worksheets to do this in. So if you are using a Google slide manipulative to do this activity, I suggest that you do a split screen with your Chromebook. So to split the screen into two side-by-side screens, you want to hit the Alt key and the bracket keys. And then you want to open up another Google tab and open up the second activity you're working on, so your manipulative. All right, so the definition of correlation is matching of rocks of similar ages in different regions. So these regions can be several miles away, 20 miles, 50 miles, but many miles away from each other. They do not have to be side by side or across the road, for instance. We'll also be using index fossils to help match up these rock layers. So in addition to the rock type, there are certain fossils that are very helpful in matching up layers that are of the same relative age. An index fossil is specifically a fossil of an organism that lived a short time on Earth and was widespread, making it useful for dating and correlating rock layers. So it's not the way the fossil formed, it's the organism that the fossil is of that makes it an index fossil. So it's an organism, represents an organism that lived a short time on Earth, but over a large area. So this is, if we were using the paper version of the activity, this is the beginning of the paper version. Correlation is the process used by geologists or stratigraphers. Stratigraphers are a specific type of geologists that work on understanding rock formations, layers of rocks, the materials that form those rocks, the processes that form those rocks, and so forth. So it's the process used by geologists to match rock layers and formations of one outcrop to rock layers and formations of another outcrop that are of similar age. Correlation is done by matching up rock layers, rock types, grain size, the presence of fossils, and other features that are very distinctive in those layers. So it also, the correlation of rock layers has given geologists an understanding of another principle of faunal succession. Sedimentary rock layers contain fossilized plants and animals. The fossils succeed each other vertically in a specific reliable order that can be identified over wide horizontal distances. So this specific order of fossils can be actually seen worldwide, where more simpler organisms are fossilized in the lower layers and the organisms become more complex as the layers get younger. We are still learning about relative age dating. Relative age dating is placing geologic events in their proper sequence from oldest to youngest. When we finish the correlation activities, we will be going on to the next topic, which is absolute geologic age, which is actually figuring out the numerical value of the age of the rock layer and then assigning that value to it. If you look at the diagram that's on the screen, there are numerical ages given. There's a lava flow that's 450 million years old, granite that's 480 million years old. Those would be examples of absolute ages. But relative age dating, remember, is older events, listing them from oldest to youngest. So the granite is older than this layer containing the trilobite and brachiopod fossils that are above it. That's an example of relative dating. All right, so here's our first example. And you don't have this in your manipulative. It is, however, there is one copy of it in the paper version of this activity. So we're going to just do this to understand the basics of correlation and the procedures that we're going to use for the remainder of this activity. And also I'm going to use this as an example as to why just correlating rock types is not the most effective way to correlate rock layers. So here we have two rock columns that contain some shale and some sandstone and some limestone. And we can see that there's 3 layers of sandstone in both of them, 1 layer of shale in both of them, 1 layer of limestone in both of them. So I'm going to start with the oldest layer at the bottom. I'm going to correlate the 2 layers of sandstone. So when I correlate these layers, I'm going to draw lines that connect the top edge of the layer and lines that connect the bottom edges of the layers together. So that area in between that double line represents a layer of rock that would have existed there in the past, but now is gone, or we just can't see it because it's not exposed at the surface like that particular layer. It's important to draw that line above and below. And for the activity we're doing after this, we're going to be correlating 15 columns along the border of Pennsylvania and New York State, and you will have to do it this way because we're going to be filling in those regions. So it's very important that you just learn the procedure now and stick to that procedure. All right, so the next layer that I'm going to correlate is this limestone. So I just chose it randomly, to be honest, and that's why this particular part of the activity is representative of why just correlating by rock types is not the most effective. But just follow along for now, and this whole point will make sense here as I go through this. So I've correlated 2 sandstone layers and 2 limestone layers, and I can't correlate anything else because I don't want to run lines that are across from each other, because if I did that, if I crossed lines, I would be saying that that older layers are forming after younger layers, and I just can't do that. So you can't cross any lines. No crossing of lines between the columns. All right, so the next thing we're going to do is we're going to number them. So the oldest event is the first thing that happened, and that is on the bottom. So I'm going to number those 2 sandstone sections as 1. I'm going to number them both the same thing because I've correlated them. I'm saying they are the same. So they formed at the same time. Now for the next one, 2 is either going to be here or 2 is either going to be here. So what I have to do is I have to figure out which one's the oldest. Well, I've correlated this limestone with this limestone up here. So I'm saying that this is younger, because I've said it's the same thing, is younger than this layer. So this one's 2. And then it's the same argument for the shale above that, and the same argument for the sandstone above that. And now I can make this limestone the 5th one. And because I've connected these together, I've correlated them. The one on this side is also a 5. And then this one formed 6th, this one formed 7th, and this one formed 8th. And of course I have a whole list here from oldest to youngest. All right, so that's one way I could correlate this, but as you've probably recognized that there are other ways I could have done this. There are other possibilities. So just doing this by rock type, I could correlate them this way. And then I have to figure out which one's my oldest. That is here or here, but I've correlated this. So I've said these are the same thing. So this is obviously younger than this one. So this one's number 1. This one's number 2. This one's number 3. And then number 4. Now I matched these, so this is 4 also. And these are the same, so they're both 5. And then 6, 7, 8. And then there's my order along the side. Sandstone 1, sandstone 2, sandstone or shale 3, sandstone 4, limestone 5, sandstone 6, sandstone 7, shale 8. Of course, I could correlate them another way. I could go this way. And then what that would do is that would make this one the oldest, and this one's formed second, this one formed third, this one formed fourth, this one formed fifth, sixth, and seventh. So the point is, in doing all these examples using the same two columns, is that correlating rocks just by their type is not efficient, effective, or often correct. So additional information is required. Some of that additional information could be going to those rock formations and actually examining the rock. Maybe the sandstones are, maybe number 3 there is a red sandstone, and I could match it up easily in the other location because it's the same sandstone. Another thing, which is what scientists typically use, is fossils. And that's what we're going to look at from here on out. Fossils. We're going to incorporate the use of index fossils in our correlation methods. So again, this diagram is showing 2 different rock columns with different rock types. But notice the fossils are there. Here we have an ammonite fossil in sandstone, and we have correlated it to a limestone layer that contains the ammonite fossil. Even though these aren't the same rock types, we've correlated them together because the index fossil tells us that they're the same age. So why would the 2 rock types be different? Well, refer back to an earlier lesson. We were learning about rocks and sediment sizes. And then remember what you learned in your environmental science class when you learned about streams and rivers. The streams and rivers that empty into the oceans are carrying sediment with them. The heavier material gets deposited first, closest to the shore, and then the lighter material is carried out further. So the lighter material, the sand, gets deposited further out beyond the gravel. And then the silt gets deposited after the sand, and the clay gets deposited after the silt. So all of those materials are being deposited at the same time. If ammonites, and ammonites lived up, they went extinct with the dinosaurs, so ammonites don't exist anymore. But if ammonites died and then were covered by sand at the same time in the deep ocean as more ammonites were covered with shale, they would be the same age. But the sediments have changed depending on how far out they are and where they settle out. So there's typically a transition zone where sediments are being deposited, a transition zone where one size transitions into a smaller size the further away you get. So it's much more reliable to match up layers by the fossil type than it is by the rock type. All right, this is just another example showing the correlation of a gastropod in 3 different layers. Notice that the brachiopod here does not make a good index fossil because it is found almost in the entire column here. So it does not make a very good index fossil. But the gastropod does because it's only shown in 1 layer each. The fish and the brachiopod are shown in multiple layers, so they do not make a good index fossil. All right, so on to the first example you have in your manipulative. So notice that we've eliminated the rock types, and now all we have are letters that represent different types of fossils. So we're going to correlate these layers based on the fossils. So we're going to correlate the oldest layer first, and that's on the bottom. So we're going to correlate the layer in column 1 that contains fossil X to the layer in column 2 that also contains fossil X. And then the next layer is that ash layer. We're going to correlate the ash layer. So it formed after the layer containing fossil X. And then the layer containing fossil O is deposited on top of the ash layer. And then we have a layer containing T and a layer containing U. Well, we're going to correlate U with U in the columns. And notice that in column 1, there is a wavy line. That represents an erosion surface. It is a buried erosion surface, so that is an unconformity. The unconformity suggests that there's material missing. And since there's a layer containing fossil T in column 2, well, we would probably make the assumption that there was a layer in column 1 that likely contained fossil T as well. So the layer containing fossil T is formed next, followed by the layer that contained fossil U, and then last is our layer that contains fossil V. All right, so that's an example of correlation. So now, if you have the paper version of this activity, you're going to draw those correlation lines, and you're going to decide what the order is and record that on your paper. If you are using the manipulative, you will go to this slide here and notice that all of these little lines you can move around. So you're going to match them up. You're going to drag them to their proper locations. So I've correlated X. Now I'm going to correlate the ash layer. And I'm going to correlate the O layer. And I'm going to correlate the U layers, like so. And then I need to place the events into their proper sequence. So X formed first, so that is the oldest. And I'm going to drag that down. The ash layer formed next. I'm going to drag that down. Whoops, grabbed the wrong one. Ash. And the O layer formed next. So I'm going to drag that down. Whoops, grabbing the wrong one again. O. And then T or U is next. So there's a U up here. So that means T has to be next. Followed by U. And then V. Okay, so that's how you do the manipulative. All right, back to the lesson. All right, the next one. Oh, let me pop all that back in there. All right, so a couple questions about that. Why is the layer with the index fossil T missing in outcrop 1? Well, there is a disconformity between the layers containing fossils O and U. This means the layer containing fossil T was likely removed by erosion. And then the next question, I wouldn't expect you to be able to answer this yet because we haven't covered this material. This is our next topic. What are some of the characteristics of a volcanic ash deposit that makes it an excellent geologic time marker? Well, a volcanic ash deposit generally contains unstable radioactive elements which can be used to determine absolute ages of material. And ash generally falls over a large area so that it is very useful as a marker to identify layers that are the same age. All right, so correlation of layers by fossils. So what I'd like you to do is go ahead and go to your manipulative, or if you're doing the paper worksheet, go ahead and correlate the two columns, and then come up with an oldest to youngest list of events. And I'd like you to pause my video at this point and go ahead and do that. Welcome back. Now it's time to check your answers. So we're going to correlate the two layers that contain O. And then next we're going to correlate the two layers that contain Z. We're then going to correlate the two layers that contain T. And then the two layers that contain U. And then H. And then J. All right, so next we need to identify the oldest and from the oldest to the youngest layers. So our oldest layer is on the bottom. Our choices are Y or O. So because there in the first column, there is fossil O in the layer above fossil Y. Fossil Y is our oldest. So it goes first. And then after that is O. And then we have M or Z. So here above the M is a Z. So M is next, followed by N, and then Z. Our next choice is S or T. Well, if we look over here at our column that contains S, there's a T above it. So S is next. Then T, then U. And then above U, we have an H or a P. Above the P, there is an H, so P is next. Followed by H, followed by J, and the last thing, our youngest event, is F. So the order is Y, O, M, N, Z, S, T, U, P, H, J, and F. All right, next. All right, this one's a little more complex. So what you're going to do now is you're going to correlate 4 columns. You're going to correlate column 1 with column 2, and then you're going to correlate column 2 with column 3, and finally you're going to correlate column 3 with column 4. And then you're going to number them, and then at the bottom you write the letters out, and if you have it correct, there will be a special message for you. So go ahead and stop the video again and complete this activity. Welcome back. Now it's time to check your answers. So we're going to correlate column 2 and 3. So I'm correlating U, I'm correlating H, I'm correlating R and E. Then I also want to correlate the second and third columns. We're going to correlate layer E. And then we're going to correlate columns 3 and 4. So there is A, and correlate the layer containing T, and the layer containing J, the layer containing B, and the layer containing fossil I. Okay, once we have it correlated, it's time to number the layers. So our oldest layer is on the bottom, but we have 4 columns to examine. So our oldest layers are S, U, E, and A. So A here is located above E, so it can't be A. The layer containing fossil E is located up here, well above U, so it can't be E. And the layer containing U is above S, so it can't be U. We're starting with S. Okay? Now our choices are U, E, and A, and we've already eliminated E and A as being next for the same reasons we eliminated it when S was number 1. So U is number 2. Now our choices are H, C, E, and A. Well, we can still eliminate E and A because remember E is way up here. So C and H. Well, look, there's an H above C, so that means C is older. C is number 3. Next, H is number 4. And then we have G and R. So there's an R above G, so that means G is older. G is number 5. And then R. And then E. Now remember, there's an E over here, so we have to label it 7 as well, because they're the same age. Next, we have T, or A? Well, there's a T above A, so that means A is older. So A is 8, followed by T. They are all 9. Followed by J. And now our choice is O or B. Well, there's a B above O, so O is older. That's 11. Followed by B. Now K or I. There's an I above K, so K is older. And then I, and then D. And then when you fill out all the letters, you get this message: such great job, kid. All right, our next example is correlation of layers by rock type. So there are no fossils shown in this activity, but all the rock types are different. Now, this is highly unlikely. The purpose of this activity is just to teach you, to give you more practice of correlating rock layers. In the real world, in the natural environment, this is not realistic. So let's go ahead and stop the video and complete this exercise, and then come back and check your answer. Welcome back. Let's go ahead and check your answer. Check your correlation. And then check your numbering. All right, the oldest one has to be on the bottom, so it's one of these. So it's not this pattern. This is schist, because there's schist here above the gneiss. So now it's either gneiss or granite. Well, there's gneiss above the granite, so granite is number 1. So the gneiss is number 2. And then our choices are schist and conglomerate. Well, there's conglomerate above the schist, so the schist is next. And then our choices are conglomerate and basalt. Well, there's basalt above conglomerate, so conglomerate is next. And then our choices are sandstone and basalt. Well, there's basalt above the sandstone, so sandstone is next. And then our choices are basalt and limestone. So the basalt is next. And then we have limestone or shale. Well, there's shale above the limestone, so the limestone is next. All right, and there is the numbering. So one last thing I wanted to share with you. If you have the paper version of this activity, you have this last activity to do. If you have the manipulative, this is not part of your activity. So now the last thing you're going to do is you're going to create a stratigraphic column. That's one column that represents the formation of all these rock types in their correct order. So you're going to start with the oldest rock layer, which is the granite. And then you're going to draw the granite pattern at the bottom and then label it granite. And then the next thing is gneiss. You're going to draw a pattern of gneiss and label it gneiss. And you're going to keep going until you have the entire column completed. All right, and then there's a separate activity, either paper or as a manipulative in Google Classroom, where you will be correlating this diagram and then also this diagram for a separate grade. So you're going to be handing in your practice, either paper version or the manipulative version, and as a separate activity, you're going to hand in this correlation as a grade for understanding. All right, thank you for joining this video and have a nice day.